Just as with every protocol, there are some very specific common issues and problems and their resulting resolution that's found within the next couple of slides we're going to be looking at. As with other protocols, we're going to be looking at potential problems that may cause neighbor relationships to fail in formation. In addition, some problems with route advertisement, routes not being injected into the table correctly, routes missing from the table, and then some address summarization issues or problems. Now, there could be a number of different reasons or issues why a neighbor relationship is not being formed. One of the causes could be that the layer 2 process or the interface is down. And the easiest way to be able to determine if this is a problem when you have a neighbor relationship not forming and it's stuck in active or idle state is execute the show interface slot port, for instance, fast Ethernet 0.0 or gigabit Ethernet 0.0 and so forth, and look on the interface that's facing the BGP peer. You should be able to see a line where it says, for instance, fast Ethernet 0/0 is up. That's talking about the physical hardware portion of it. Line protocol is up, and that's talking about the layer 2 process. You may see fast Ethernet 0/0 is up, line protocol is down, and it means the physical interface is fine, but Ethernet keep alives are not being sent and received on that interface. Sometimes that can just simply be that it's not plugged in, there isn't something on the other side, or you may have a bad cable. If, however, you see administratively down, you know it's been shut down, and you can just simply do the no shutdown command on the interface. For figuring out layer 1 and layer 2 problems, always start at layer 1 and work up and troubleshoot and solve those layer 1 and layer 2 issues on that particular interface. If it's hardware failure, if it's a cable failure, or something more subtle, that'll be the best way to take care of this particular cause. A second common cause for the failure of a neighbor relationship to form could be an incorrect IP address in the neighbor statement configured in BGP. For instance, in router R1, it should be router BGP 65001, and the neighbor statement for R6, for example, for peering, should be neighbor 10.99.99.6 remote AS 65006. Conversely, on router 6, the statement in the configuration should be router BGP 65006 and neighbor 10.99.99.1 remote AS 65001. If, for example, the IP address is wrong on either router 1 or router 6, the relationship will not form. So the easiest way to figure out if there's a problem is to first execute the show IP BGP summary command. It will show you the state of the neighbor relationship, how many prefixes, if any, are being received, and you can actually see whether the neighbor is stuck in idle or active state. It's the last column when you execute this particular command. In addition to that, you can also execute the show running configuration command to verify that the peer IP address is indeed correct. One of the things that may be helpful is to be able to go in using PuTTY or TerraTerm or Secure CRT or whatever terminal services program you're using, highlighting the BGP section, pasting the configuration into Notepad, then going to the neighbor router, doing the same thing, and then actually look to see if those neighbor configuration statements are in fact correct. If they're not correct, delete the neighbor statements and recreate them with the correct IP address. Another cause for neighbor relationships not forming, especially in eBGP, is because there's not a direct connection between them. Now remember, BGP neighbors, external BGP neighbors, do not have to be directly connected, but by default you have to have additional configuration command in order to be able to know whether or not it's been configured correctly, and it's the eBGP multi-hop command. You can use the trace route and then the peer IP to discover if the neighbor is more than one hop away. You'll be able to tell very easily by the number of different sections and hops are actually being shown in that. And if they're more than one hop away, if they're 2 or 3, you can go back into the statement, into the BGP configuration, and put in the statement neighbor, the peer IP, and eBGP multi-hop. You don't really have to put a number after it, but it's best practice just to put in the number of extra hops away that particular router is. If you don't put anything, it'll do 255 by default. But if it's 3 hops away, you can do 3. If it's 2, you can do 2. You might even just make it around 5 if you want to be just a little cautious. But either way, just try to limit it by configuration. Another thing you can do is the show TCP command. You do it from the command line, and it'll show you whether or not a TCP connection is up and in progress with that particular neighbor. You'll be able to see what it is. You'll be able to see it on TCP port 179, and it'll let you know that a TCP connection is indeed active. So that's something else that you can do. If for some reason that the eBGP multi-hop statement is not in there, you can easily add it. A third cause that's very common for neighbor relationships not forming in BGP is the failure to configure the correct key in the password statement. Easiest way to do this, if you do a show IP BGP summary and the neighbor relationships are indeed stuck in active or idle, go to the running configuration, parse through it, and look for the neighbor, peer IP address, password, and key, and make sure that key is the same on the other side of the connection. Again, this can be helpful if you go into Notepad, actually take that snippet, paste it, look at it side by side, and make sure that one or other things has not been mistyped. Remember, the key is case sensitive. If that statement is incorrect, you don't have to take the whole neighbor relationship down, or actually you don't need to delete the entire configuration. The neighbor relationship would already be down, but you can just change that one statement. You could do no neighbor, peer IP address, whatever the key number is, password, and such, and then recreate it. Make sure it's the same on both peers, and it should come up rather quickly depending on how fast you've set your timers. Another less common but still possible causes for the neighbor relationship not forming is because somehow unicast traffic between the peers is being blocked. It could be a firewall, it could be an access list, there could be a variety of different things. Most likely it's going to be something configured on the one or the other peers that may be blocking it, but if there's an intermediate device, then you need to take a good look at that configuration as well. But on the particular device in question, do the show IP interface and show access list commands. Look at all the access lists, see if anything is being applied on the interface facing that particular neighbor, and if there is, either alter the access list to allow the traffic, or you may have to alter it altogether, delete it altogether. But once you've done that, make sure it's correct, make sure the statements for peering are correct, and then obviously make sure your interface is up. But unicast traffic being blocked can indeed be a cause for neighbor relationships not forming in BGP. Another potential reason for a neighbor relationship not forming has to do with something else in the neighbor configuration that may be misconfigured. It could be timers may be mismatched. Obviously, we've already talked about the MD5 authentication needs to match. But if there's something incorrect about the neighbor statement, you have to actually look first at show IP BGP summary. Show first if the neighbor relationships aren't even shown, then the neighbor relationship is not being established. It's not been configured at all. If it's been configured, you're going to see at least active or idle, and it's going to be shown as a result of that particular command. At that point, you can use the show running config statement to be able to actually go through and parse through the configuration and actually sort through. If you only have a few entries, it's very easy. If it's a lot longer, it can be troublesome. Again, take it to Notepad, paste it there, and then you can actually use a search function to be able to find specifically what you're looking for. If there's a specific IP that's been configured, you know that's correct. You can go to that particular IP, you'll find the entire string of numbers and commands because they'll be listed in order, and that can give you an idea of being able to make some determinations about cause. If something's wrong, you can delete and recreate the neighbor relationship with the correct IP address combinations. For route advertisement, there can actually be a number of different things, but obviously first, if routes aren't being injected or advertised correctly, one of the first culprits, very commonly forgotten, is the auto summary command. Just as with BGP and EIGRP, both have automatic summarization enabled by default. If you don't issue the no auto summary command when you configure BGP, it's going to automatically summarize again to a classful boundary. This is why at the very beginning of the series, we harped a little bit on classful and classless protocols, because there are times when classful protocols or classless protocols can act in a classful manner. One of the many pieces of information that the show IP protocols command will actually display is whether or not summarization has been enabled. If you do show IP protocols, it's actually going to spell out all the different details of that particular protocol, but look specifically for the statement automatic route summarization is disabled or enabled. Now in EIGRP, it'll say is in effect or not in effect, but BGP it's going to say route summarization is enabled or route summarization is disabled. Obviously, you're looking for the disabled command. If it says something different, all you have to do is go back into the BGP configuration, router BGP, the ASN number, and just type in no auto summary, and then it will take that particular behavior away. Another reason for route advertisement problem is the particular route being injected into BGP in this case by the network statement, it is not matching a route in the IP routing table. Remember, there's a certain amount of matching that has to be done in that regard. First, execute the show IP route command, not just for a particular protocol, but just the command just like that, in order to discover if the route indeed exists in the current routing table. If the route is expected to be there and it's missing, then you have some questions to ask. Is an IGP issue going on? Was it never configured to start with? You may take the same troubleshooting principles and apply them to the IGP to see if there is a particular issue that's preventing that from being installed in the routing table. And if so, you just need to correct that. Another reason why IP routes might not be appearing in BGP just simply has to do with the process called synchronization. Synchronization basically means that it has to exist in the IP routing table through an IGP, static routes, or other means, or BGP will not advertise the route. If you execute the show IP protocols command, look for the statement IGP synchronization is enabled or disabled. If it's enabled, you need to go back into the BGP configuration and put in the no synchronization command in order for that behavior to be turned off. One final cause for a problem with route advertisement issues may have to do with redistribution, which we're going to cover a little bit more later in detail. But if redistribution has not been configured, BGP is not going to pull those routes in. The table has to be populated either through direct injection into BGP using the network statement or through redistribution. And if it's missing, then you'll be able to see where there's a problem. You can choose to use the show IP protocols command and look to see if redistribution has been configured. And if it has, you can do show running configuration, look and see where redistribution might have gone wrong. It could be that you put in an incorrect AS number or a process ID relating to OSPF, but in which case you can correct those particular issues. Now, aside from routes not being advertised correctly in BGP, you may find that certain routes are not showing up in the routing table, which is a little bit of a different issue. They sound the same, but route advertisement is the BGP process actually announcing something out. And whether or not something's being installed in the routing table is a separate issue altogether. So one of the things you may run into in this instance is the default route may not be showing up, and that may be just because it's been misconfigured. Do show IP route and first see if there's a route to the 0000 network to begin with. If it's missing from the table, it won't be able to be injected or advertised from BGP. You can also use the show running configuration command and verify that the network 0000 command is under BGP, as well as the default information originate command. They both need to be there. Either you have to either redistribute or inject BGP's default route using the network 0000 command. And if they're missing, you can actually add them to the configuration with a fair amount of ease. Another cause for routes not appearing in the routing table itself may also be because of the synchronization issue. We talked a little bit about this before with route advertisement, so we're not going to go back into those particular details. Another cause is in iBGP neighbors, you may have a problem because the iBGP neighbors are not fully meshed. Remember, when the routes are being advertised among iBGP peers, it has a TTL of 1. If they're not all fully meshed, you're not going to be able to propagate routes correctly. You can do the show IP BGP neighbors to verify that peering's happening correctly. And you can use the show running config command, and you may have to do a little bit of digging and detective work in order to be able to determine whether or not the neighbors are fully meshed. If there are connections that are missing, for instance, in the graphic that we have to the left, if these were iBGP routers and 65000, the internet router and router 1 were connected directly, and then router 1 and router 6 were connected, but there was no connection between the internet router and router 6, that would be a missing leg to a fully meshed environment. So if that kind of connection, for example, was missing, then you could use the neighbor peer IP remote autonomous system number command in order to be able to have that working correctly. And then do the show IP BGP summary command. Make sure that all the other peers that you're looking for are indeed there, and that each one of the neighbors shows all the other peers that are required. That'll be your best way of determining whether or not a fully meshed relationship has been configured. Another reason why a route may be missing from the table is the iBGP next hop is not reachable. One of the ways that you can check to see if this is an issue is do the show IP route command. examine the routing table for the required static or IGP route. And this is true even with eBGP. If the next hop route is not reachable, it's not going to be advertised. If you recall, when we did our advanced lab configurations, we actually had to have static route statements on each one of the routers in BGP to point to the loopback address of the neighbor routers because it was one hop beyond, so it had to be configured with a static route so that it would show up. If a static route is required, it's very easy to configure: IP route, prefix, mask, next hop command, and so forth. If there's some reason the IGP is failing to install the route leading to the next hop address, you may have a whole other set of issues just related to the IGP. And in that instance, you have to make sure you're looking at BGP as one sort of troubleshooting domain and the IGP as another. They depend on each other, but they can have different issues. In terms of address summarization problems, the most common cause for an aggregate not being advertised is because there isn't some part of the IP address range within the aggregate that exists already in the routing table. The easiest way to be able to determine that is do show IP route, see if any networks within that range currently exist. I keep going back to the example of the ISP I work for. If you were advertising an aggregate address 216.145.0.0 and then the mask is 255.255.252.0 and there are no 216.145 any type addresses in terms of the routing table, it's not going to advertise the aggregate. So make sure it's correctly configured and then go back and look at it again. Delete and recreate the statement or find the causes of the missing route if there are any.